Hello ladies and gentlemen, this is Mr. Mayer. In this video we will prove triangle similarity, and by the end you want to be able to say I can use a two-column proof to prove triangles similar by the SSS, or side-side-side, similarity postulate. Directions say use a two-column proof to prove the following. Diagram is not to scale. If you're confused what this statement means, it just means that the numbers may not match directly with what the size length should be comparing each other. So all these kind of look the same, but this one's saying it's shorter than this one's saying shorter than this one. Okay? Do not go by what the picture looks like, it's by what information is provided to us. Our given information, again, this is always where we're going to start our table. Our proof, this is the statement that's going to come last. This is our answer we're trying to make true. So I'm starting my table by the given information. Not very helpful, but we're going to use this information to help ourselves understand how these can be similar. Again, this is given information. So now for step 2. Anytime I'm using values for the side lengths in similar triangles, it's important to realize similar triangles have proportional side lengths between the two triangles. So what I'm going to do is I'm going to set up a proportion. I'm going to set up fractions and just make sure that they are equal to each other. Now, it does not go by the order of the letters. It's not alphabetical. That's not how we do this. What we need to do is we need to set up the values, the lengths, in reference to each other. So 12 isn't necessarily going to go with the number directly below it. Our job, the way that I always recommend you set this up, is to set up your side lengths compared to each other between the two triangles. So I'm going to match the short side over the short side. I'm going to match the medium side over the medium side. And then I'm going to match the two long sides together. Okay, this is between the two triangles. The whole purpose of this is that you are matching them up between the two triangles. So who is my shortest side in the top triangle? I'm noticing it's 12. Who is my shortest side in the bottom triangle? This is 8. The next one, medium side, the next largest is going to be 15 in the top triangle. And then I'm noticing in the bottom, the next largest is the 10. The longest side in the top triangle is this 18 over the 12 is the longest in the bottom triangle. And this isn't enough to help me. I need to make sure that all these are the same. They definitely don't look the same right now, so my job is to simplify. What can I simplify this by? What can I divide the numerator and denominator by in order to make this completely simplified? I can divide them both by 4. 12 divided by 4 is 3. 8 divided by 4 is 2. So my job, hopefully, all these are going to come out with the same exact fraction. 15 over 10. Divide both these by 5. I'm getting 3 over 2. Perfect. This one, 18 and 12, yeah, divide by 2. Yes, I can divide by 3. You're always looking for your greatest common factor. What number can go into both of these numbers is 6. So the greatest one is 6. 18 divided by 6 is 3. 12 divided by 6 is 2. I notice all these are equal. Perfect. So this is a proportion that is true. So that means I set my fractions up correctly. This is your step number 2. The reason for that, again, if you want to say that it's a proportional relationship, or if you want to just say it's given from the diagram, either one is going to work for you. Now, this information is not enough. Having just equal fractions is not enough for us. We need to know why this is applicable, why this is important to our diagram. So what I'm going to do right now is I'm going to, instead of putting the numbers, I'm going to put the side length names that represent them. So 12 is side AB. I'm going to put AB in its place. Okay, so I'm putting all the actual names of the side lengths in the place of the numbers. And anytime I replace things, put something in its place, this is called substitution. So I'm substituting all of the values of the actual names of the side lengths into the values from step number 2. Now what I'm noticing in step number 3 is I have all 3 side lengths proportional. All 3 sides are proportional. This means that the side-side-side SSS similarity postulate is true. Anytime you use a similarity postulate, what you have proven is that the two triangles are similar. So we've done our job. Everything is complete. Just make sure for step number 4 that you are writing your proof statement exactly as they asked to begin with. So triangle ABC is similar to triangle XWY because that is the order they asked for originally. If you messed up the order, make sure you go ahead and fix it. Thank you all for tuning in and hope you do well on your assessment.